Welcome everyone, and thank you for joining us today. Today's webinar is presented by Sports Field Management Association. This week, we will begin our four-part series of post-conference education. Our featured speaker today is Thomas Shay, PE. Tom is a graduate of the University of Rochester with a BS in geomechanics, where he played football and he continued on to earn an MBA from Pace University in strategic management. He is a licensed professional engineer with 15 plus years of experience and currently a principal technical manager and the sports and recreation practice leader at Woodard and Curran, an integrated science and engineering consulting firm headquartered in Portland, Maine, with offices around the US. Tom is a site/civil engineer experienced in planning, permitting, design, and construction administration of land development projects, oftentimes in more complex, sensitive, and constrained environments, where he has developed a specialization in outdoor sports and recreation facilities while provoking demand for more holistic solutions that are financially, socially, and environmentally responsible. He is also a member of the ASBA and STC. Today, he will be presenting Pursuing Infill Depth Perfection in Synthetic Turf Systems. Attendees will be muted during the presentation. If you have any questions, please use the Q&A or the chat feature. Please type in your questions and Tom will answer them following the presentation. Tom, thank you for joining us today. You can go ahead and get started.
Thank you, Kristen. I appreciate it very much. Good afternoon, and thank you to all those attending. Appreciate the opportunity to share this information with you all. Hope to provide some insight and value to your day-to-day operation. And thank you to the SFMA for the opportunity to present on this topic. And must say I'm always impressed with the knowledge and passion of this group on the sports field manager's side. Quick overview, we'll jump through just an introduction, review the learning objectives, just to be ultra clear, look at the project life cycle, and then kind of zoom in or focus on the planning and design, the installation, and spend most of our time there. Certainly have to mention O&M, sum it up with some takeaways, and then ultimately, hopefully be a little thought-provoking of what the future might hold on this topic. The content for this presentation on synthetic turf infill started originally simply with the intent to confirm that sufficient infill material was being delivered and installed. In that during construction, enacting our capacity as the owner's representative, we were trying to make sure that the owners got the material that they should have. As we gathered more data, learned more, we saw inconsistencies and challenges, and felt obligated to bring this information out to the industry. And circled the wagons a bit and talked to various industry colleagues and other designers and field testers and contractors and manufacturers, and they all felt similarly that this was a place to spend some time. So here we are now, with the field managers, which is probably the most exciting group to spend time with, to be honest with you. So I'll bounce around a bit at the beginning of the presentation, and then try to each as we move forward, we'll zoom in and focus, ultimately focusing on infill. Certainly won't have all the answers today, but I want to bring more awareness and the opportunity for improvement on the installation side of synthetic turf fields as we all collectively pursue higher performing systems. As far as learning objectives go, want you to pass along the what we see as limitations on current infill depth measurement practices. We'll visually demonstrate and go through a bunch of examples of heat maps of a very significant number of infill depths and how they vary. Run through some lessons learned and opportunity for improvement, and again, be thought-provoking, hopefully for this group, and keep the conversation moving in a positive forward direction. So in this case, again, starting way zoomed out, I like to start with the project life cycle and say each subsequent phase of the project is the most important phase of the project. That might not be completely clear, without some further explanation, but essentially we can come up with a great plan and have our bases covered financially, and enough money in the budget to do the right project, and we can come up with a great design, perfect design even, let's say. But if that's not installed properly or completely, it was all for naught, essentially. And then again, we have a great design, a great installation, and the O&M falls short. You're not getting the value out of the system in whatever capacity. So as we move through this presentation, infill is a important contributor and component to each of these phases. It influences costs, it influences the system components in the design, it influences the installation, and then ultimately the maintenance, as you all know. So, and then even replacement. The infill influences replacement, whether it can be reused or disposed of or composted. So, the field life cycle, infill is an extremely important contributor. Again, zooming in a bit, from a design perspective, our goal is to provide synthetic turf systems that perform more similarly to high quality, well-maintained, high quality natural grass surfaces, with available technology, essentially, and simultaneously generating more holistic solutions. This approach must consider and take into account not just the financial aspects, but also the environmental and the social aspects. So that's more of a triple bottom line approach to the process. Or we're thinking about people, planet, and profit. So each of those having equal priority, essentially, for looking to maximize values for stakeholders, and think about the long-term results of our actions. And I want to highlight that as these designs progress and projects progress, we have to be thinking about the long-term results of our actions. And again, infill plays an important role in that endeavor. When we think about people, correlating these first few bullets here, the particular sport we're designing for, and the performance of that particular surface, certainly the safety and the inclusiveness and who can use that field are all the people or the social aspect of that surface. Environmental responsibility is pretty straightforward. We need to design and choose materials and manage them in a responsible manner. Of course, cost and the financial piece is pretty self-explanatory, and oftentimes the first and the largest component of decision making and accounting. But again, different infills have different costs. Different infills have different environmental impacts, let's call it, at the various stages of the project. And type of infill has different influence on the sport or the performance, right? So we can correlate all of those. And then the last couple of bullets there sort of span all of those, those criteria or aspects, longevity, how long the infill lasts, impacts costs, and it impacts the other environmental aspects, right? Maintenance certainly impacts all three: people, planet, and profit, right? How much effort it takes is not only burdensome to people, it's more costly. And clearly the maintenance, if infill is leaving the field, there is an environmental aspect to that. So again, trying to paint the picture that we don't want to just meet regulations or meet today's minimum standards, but begin to move beyond cost, move beyond surface performance to address next level issues, considering the environment, and start to address issues like surface heat and heat on effects and true recycling. And again, infill plays an important role in all of these. So again, a little bit further, digging in. For me, my perspective and philosophy is infill largely dictates the synthetic turf system. When we look at how infill influences the turf, there might be better combination of fibers, whether it be a slit film or a monofilament or a combination, and then similarly how the stitch gauge on that carpet and how close the turf fiber rows, each infill, depending on how much it might migrate or not, influences the turf system. Certainly, if an infill has, or if it's a resilient infill, performance infill, it may not need as, it may not rely as much on the shock pad, for example. So certainly the infill choice influences whether a shock pad needs to be used, which is almost always recommended from my perspective, but certainly the quality or the how much the pad is the workhorse in that system. And then ultimately the compatibility of the components. We've never seen more options on the table when it comes to carpet, turf carpet properties and different fiber types and pile heights and densities and root zone or thatch versus various shock pad options versus various infill options. So, we oftentimes in our design side talk about Franken specs or specs that are just thrown together for a system that is potentially not compatible by the various suppliers, not deemed compatible by the various suppliers. So that's something we certainly need to be aware of. So getting beyond the system makeup, and again looking at infill depth now, there are various criteria that infill depth is influenced by, right, depending upon the sport, whether or not we need resilience out of that infill, or any sort of bounce or impact absorption, and the sensitivity to that, meaning maybe it's slightly resilient versus totally non-resilient. The ingredients, when I say ingredients, it's the infill recipe. For example, most are familiar with the SBR, the sand ballast, and the SBR system, or any of the systems that have sand at the bottom. That's there are other infills obviously that are just a homogeneous single component. So the ingredients of the system and its impact on infill depth, and we'll talk more about that. We need to think about warranties as it relates to infill depth, and what those warranties say as far as how much infill is required to be maintained in the system for the warranty. We need to think about replacement and reuse or disposal of that infill. When we think about the portion of infill in the turf system, upwards of 90% of the weight or volume of the synthetic turf field could be in the infill. So, as we reduce the amount of infill in the field, we also reduce the amount of a material that needs to be handled on subsequent phases of the project, such as replacement. And then lastly, infill depth standards and tolerances, and what they actually, where standards exist, what do they say about infill depth? So we'll talk a little bit more about that here in a minute. Right now, actually. So when it comes to infill depth standards, there are a couple primary go-to resources, and these are of course international standards in the absence of really any American standards or widespread American standards for infill depth. So FIFA and World Rugby are the two entities that have infill depth standards or guidance as part of their programming. So FIFA test method 21 specifies 19 test locations, and that doesn't have any sort of performance pass fail criteria as far as FIFA goes, as far as I'm aware, and they actually list it next to that criteria. It's for information only, so they're collecting that data, but there's they don't do anything with it beyond general reference. So World Rugby, on the other hand, again tests 19 test locations, and actually specify that 17 of those test locations have to be within 5 millimeters of each other. So they're putting a 5 millimeter tolerance on 17 of those, where there can be 2 outliers. So those are both relying on the EN 1969 standard, and you can see in the upper right here is the FIFA. I recognize it's quite small, but the point here is there's prescribed test locations from FIFA, 19 of them, and then similarly here in the green, World Rugby is telling the test lab where to test that surface as well. And that has some implications, as we'll see. 19 tests, it's not very many. And then at these locations, somebody's determined that they're the best if you're only testing 19 locations. But as we'll see, there's a lot that happens in between those locations. ASTM has had a working standard. Again, as far as I'm aware, it's still working standard for quite some time as it relates to infill depth measurements. The Synthetic Turf Council has some performance guidelines, and they generally state that the infill depths should be within plus or minus 15% of the synthetic turf manufacturer's requirements. Notably, not necessarily a standard, but we must take into account the synthetic turf manufacturer's specifications and what they may or may not say as it relates to infill depth. And then related, I would say, is the evenness, or what various entities call either evenness, surface regularity, or planarity of the surface. So while that's not directly telling you what your infill depths need to be, FIFA method 12, for example, gives some guidance where the surface must be within plus or minus a certain number of millimeters at all the test locations under a straight edge. So that certainly is influenced by the quality of the infill installation and the various infill depths, in the locations of that particular straight edge as it's dragged across the surface. So there are some guiding principles here, but again, I think I'd reiterate, in the US, there's not a go-to standard for infill depths, or a sport governing body that pushes infill, any sort of infill depth standard. So in this slide here, there's a lot to look at, but what we looked at was for some quantitative data and a very limited data set, but we looked at a 2 1/4 inch dual fiber turf, no thatch or root zone, no pad, and it's a 60-40 SBR sand infill mix, and tested vertical deformation, shock absorption, energy restitution. So those will be your advanced artificial athlete tests. Looked at rotational resistance, looked at Gmax, and looked at head injury criteria at 3 different infill depths. 5/8 of an inch of infill, obviously super low, 1 1/4 infill depth, and 1 5/8 depth. And ultimately bracketing those, the minimum and maximum standards where they exist. So in this case, what we wanted to highlight was less, not necessarily what the values were, but more the change of those values. And if you look at the values and do some quick math, in this first column here, the vertical deformation varied 33% in those, across those measurements in infill depths. In the second column here, the shock absorption varied 17%. As we move to the right, energy restitution did not vary a significant amount, on the order of 10%. Rotational resistance, 20% change. Gmax, 42% change across those infill depths. And the head injury criteria didn't vary much, on the order of 7%, but notably none of those passed the one turf concept or World Rugby head injury criteria, critical fall height. So anyway, takeaway here is very clearly that there's significant performance differences dependent upon infill depth. And one might say 5/8 inch of infill in a 2 1/4 pile system, that's crazy. But I'll show you some pictures on the back end of this presentation where that condition or worse actually does exist. So hang in there and we'll check that out. So many times, certainly at the end of summer, where a lot of, certainly in the institutional world of high schools and college universities, we get to the end of the construction season, which is typically slammed in the summer between classes and fall sports, and get to this point here in this photo, and everything's green and the lines are in, and there's the 20 installers aren't spread out across the field anymore, and everybody's feeling pretty good. So field's essentially installed, and some may say this looks perfect. So looking quite literally from a different angle, here's a logical expectation for what owners think they're getting, and maybe even what designers and installers expect to have occurred. This is what owners are buying. This is what testing labs test. And what I mean by that is, consistent infill depth, regardless of infill type, where, there is a relatively even, consistent fiber reveal above that surface. So that's what everybody, again, logically, intuitively, rationally expects to have occurred. Looking from that same perspective, here's a look at what owners are getting in some cases, and certainly not all cases. But this is what they're getting, at least without some additional intervention. This is exaggerated a bit from a horizontal or lateral scale for clarity and presentation purposes, but these are the types of ranges and variations of infill depths being witnessed across the field surface upon closer inspection. And in this case, we have sort of valleys and peaks of infill where there's on the order of 10 to 15 millimeters in some instances of infill variation. And it's important to note, while we're showing a homogeneous sort of section here of sand or rubber, you can imagine what happens if the sand ballast, if it's a dual, two types of infill, sand ballast and a performance infill at the surface, what the peaks and valleys of, say, the sand ballast are, and then the filling the gaps with the performance infill. So in this instance, you might only have a little bit of performance infill if the green were the sand, and in another, this space here, you'd have significantly more performance infill, and of course that performs differently. So clearly that condition can be exacerbated with a multi-ingredient recipe of infill. So, in my world, often dealing with construction and contractors, we're exposed to RFIs, requests for information. So we're looking to, turn the tide there and have a new RFI to throw back at them, and it's room for improvement. This is what we're looking to particularly focus on and call attention to, kind of, why we're here today. And the good or the great news is that there appears to be some low-hanging fruit based on our experience, and this is what we wanted to make sure to pass on to others in the industry. And a few reasons why we think there's room for improvement right off the bat is there are a lot of new systems, and new systems, again, being different types of infill in this case, that including pads. Some installers, really depends on what installation crew you get and what their experience is, whether they're they sew seams or glue seams, and if they're used to installing only sand and chrome rubber infill, or they have experience to other alternatives, or if they install over shock pads or not. So each of those things influences pretty significantly, and then again, it depends on the installation crew and what they're typically exposed to. Again, hit on it a little bit already, but the schedule, what I like to term final component completion stress, and the infill being the final component of these fields. Again, so many of us in colder climates, where you have a constrained, shortened construction season already, and then you put these projects in the summer between classes and fall sports, and then you have all these fields that are being installed. And then this infill component is being done at the end of that season. So each of those just really constricts, and all of these fields are getting infill at the same time of year. So it's a stressful time. So essentially what we find is the installers, infill's delivered, they throw it in the hopper, they spread it, they leave. That's the process. And that leads to the third bullet here, is really inconsistent approaches and methods and equipment. We see drop spreaders and broadcast spreaders, and we see some equipment can monitor infill usage and some can't. Some measure infill depths, most do not. So it's just really inconsistent. And again, depends on the install crew and it depends on the equipment that's closest to that team when they're ready to roll. And just to pick on these photos a little bit, clearly this, lacrosse goal area, crease area, you can see the excess infill spread there in front of the goal. And we know why that's the case. That's one of the highest use areas and impacted areas on a sports field. And but very clearly, if you can see more black there, that surface is playing very differently than the rest. And if it's overfilled, it's going to be slippery. If it's not overfilled, then they lost a lot of fiber. So either way, that surface is playing quite differently than it was designed to. This middle photo here is actually an installation where this was the first time installation of a natural or organic infill. And many of the synthetic turf fibers got trapped under the infill. So, lots of infill fibers are below the infill surface. And then just an infill depth gauge, which I'm sure all of you are aware of, but something we'd certainly like to see more, everybody using more of, designers, installers, field maintainers, and so on. So here's the point where we're going to look at a bunch of different infill maps. So this is a general introduction to the infill map as we start to look at the first one here. But back in about 2018, we started to get more advanced in our process. But it started out really with a clipboard and a drawing, and taking some infill depths. Started with 10, and then it went to 20 and 40, and soon we were realizing that those are really insufficient level of observation and inspection infill depth measurements on these fields, considering so many are 70, 80, 90, 100,000, 200,000 square feet. So our process then moved to what you're looking at here, which is infill depth measurements, geolocated with a handheld GPS device down to sub 1 meter, taking on the order of 100 to 300 infill depth measurements across the field, importing that data into a GIS program, and developing heat maps, as you see here, based on that data. So like I say, we took a bunch of infill depth maps, gave it to our talented GIS people. They did some wizardry, and out popped these maps. We went this route again from a clipboard and a pen, black and white, to a colored map because we recognized very quickly the efficiency of a color-coded visual. And again, I think we'll beat the dead horse a little bit here as we move through this, looking at 8 or 9 different projects. But you'll soon get to the point where you'll see the efficiency of these particular maps as a tool in being able to say focus on certain portions of the field that need maintenance or need attention. So each of these maps will be very similar. They'll all have similar components. So we have the primary component being the color-coded field. We have an infill depth range over here, and I recognize that not everybody or probably nobody can actually read these, and you don't need to, aside from seeing the visual. But each map had another chart that just kind of showed us where this tallied up the infill depths and the interpolations between them. This is another visual to see where the measurements land kind of across the range. And then we have an infill depth summary, which just tells us how many measurements we took on that particular field, looked at the minimum and maximum value to get the range, and then looked at the average. So in this particular case, we had a target infill depth of 1 inch, 25.4 millimeters. This map includes 306 infill depth measurements. The range of those measurements is minimum of 17 millimeters, a maximum of 30 millimeters, and the field averaged 24.4 millimeters. So about a millimeter low across that field surface. So what we intended with our specifications, to jump back a little bit, is we're specifying that the contractor, with a minimum of 100 infill depth measurements, the average infill depth should be, in this case, 25.4. That's to give us feedback on if the right amount of material was delivered to the project for plus minus hitting the average depth, and then also putting a plus or minus 10% tolerance on that target infill depth. So usually a few millimeters, 2 to 3 millimeters below and 2 to 3 millimeters above, so 5 or 6 millimeter range. And that's what we set out to see if it was even possible, to be honest. Could installers hit that target? And what we see here in this particular example is that the light pink shades, so kind of underneath the laser pointer here, up through the light purple or the lightest purple, including the green, were areas that this field was in that plus or minus 10% tolerance. So the deeper reds or the oranges or the deeper purples were areas, in this case, deeper purple, the field was low. I'm sorry, the field was high, infill was high. The deeper reds and golds, the infill was low. Again, so in this case, we can see, kind of throughout the body of the field, here's the easiest place to pick on. The field was 2, 3, 4, 5 millimeters low on infill here. So that was, kind of this was one of our first projects, and we got to see the, the color code, how the colors worked for us. So again, moving forward. And I will say, our process evolved and got better as we move forward with time and experience and projects under our belt. Eventually we're getting to a place where green is good and red is bad. So we'll get there, so bear with me. But this was I failed to mention on the last one, this was a new installation. So this was not an old project, this was a new installation. And similarly, this second map, new installation. So this particular map is the second iteration of the infill depth measurements on this particular field. So we had done this one time prior, so it was more variability. So in this case, 216 measurements. The range was 18 to 31 millimeters. We again had a target of 25 millimeters, so we were -7 and +6 on that. But this field averaged 26.32 millimeters. So what this told us is we had the infill on site with an average, meeting or exceeding slightly the target, but again had pretty significant variability. Where in this case, again, the light pink, which would be here, through the light purple, including the greens, are good. Again, the dark purples or the reds and oranges are low or high. So, I like to pick on this example for, where right off the bat on day one, if this field, didn't get any intervention, we didn't say, hey, the infill depths are low here, corner kick, day one, low. Same thing, corner kick, low, right? Goal box, low. So again, our goal here is to give you all as sports field managers, hopefully a perfect field on day one, not an incomplete field on day one. This is quite an interesting case. The left-hand portion of this field, I'm going to circle it here. Hopefully there's not too much of a delay, but the left-hand third or so of this field was about 7 years old. The right-hand 2/3, which is the soccer and football field, the rectangle field, was about a year old when we did these measurements. I had to do some field replacement for whatever reason. In this case, we had a target infill depth of 32 millimeters. We did 172 infill depth measurements. The range on our measurements was 7 millimeters to 35 millimeters. So 28 millimeter range from low to high. And the field average was 28.7 millimeters. So this whole field averaged 3 to 4 millimeters low. Again, you'd say, okay, for the 1-year-old field, you'd expect that to be less so. Maybe the 7-year-old portion would be low, but you really can't tell the difference between these two. To be honest, you would have never have guessed that the right-hand portion was 6 years newer. So, again, good feedback here as it relates to, case where we have a new field right next to an old portion of a field. And again, in this case is where we got our range. Green would have been good. In this case, you see all that red and orange because the entire field is essentially 3 to 4 millimeters low, with the exception of the areas that are green and purple. So coincidentally, the entrance to the field is here. So maybe that's what got the infill on the installation. We're not quite sure. So again, another case, this is a 6-year-old field. Again, here, I just saw a question actually pop up, and I will go back, but it's timely since we're here. This field is plowed. The question was, is the map C, is this field in map C plowed? And it is plowed. I do know, however, that the majority of the snow is actually piled on this end. So maybe the opposite of what you're thinking if they were plowing snow to the top side here. But anyway, a good conversation there in the event that that's there's some more thoughts, but it is plowed, like many are, at least in the colder climates. Map D here, 6-year-old field, 321 measurements. The range was 15 millimeters to 39 millimeters, so 24 millimeter range from high to low. This field averaged 30 millimeters, where the target would have been 38. So again, this field is completely blue because it's low. So there's, a green would have been good, but we didn't even get to green on this one because the entire field is measuring 8 to 9 millimeters low on infill. Map E. Again, this is a new install, and now we're at the point in the process, evolution of this process, where we as the engineer, who is involved during construction, are doing a better job conveying expectations to the installer, where we have the discussion with them up front. Hey, here's the specification, here's the average target depth, here's the tolerance, we expect you to hit that. We're going to come out and measure it. Make sure you measure it before we measure it. And so that's how the process is getting conveyed, pre-installation meeting. And we can see it's starting to help, where again, in this case, green is good. Red is low, blue is high. So we can see with 218 measurements on this field, the target depth was 25 millimeters. The average was 25 millimeters. So we're confident we had the material on site. The range in this case was 14 to 34 millimeters. So there's still quite a range, and there typically is. It can be smaller, but there is usually a few really low spots that bring the low end of the range down. But what you can see here, and again is quite common, is all of these areas of red along the sideline. A lot of times, in particular, if a broadcast spreader is being used for infill, we see the sidelines being significantly low. And we expect that the reason is because they're trying not to throw as much infill outside of the field surface. So anyway, something to be particularly sort of critical of. And then again, in this case, we saw the soccer goal box and areas of lacrosse goals on day one are low, with some areas within the body of the field being a millimeter or two high. Again, moving forward, these, we're pretty happy when we see a field like this, to be honest with you. This is a pretty similar scenario as the last one. Now, with the exception of this is 3 fields side by side. So there's actually 727 infill depth measurements on this field, about 240 per field. The range here was 17 millimeters to 29 millimeters on a 25 millimeter target. At the time of this map, the average was 24 millimeters on this field. So again, what we see here, what was really bringing the average down was essentially the entire perimeter of this field was significantly low on infill, 2, 3, 4 millimeters low, essentially, and that's a significant amount of infill, and super sacks of infill. But this again is where the process is starting to work, and had not only a pre-installation meeting, we worked with these installers previously, so they knew what to expect, and that makes a big difference. This is probably one of the closest projects to perfection, I guess you could say. 3 fields. Each of these fields got about 100 infill depth measurements, all green on this field on the upper left. The range was 28 to 35 millimeters on a target of 32 millimeters. So we're really, kind of dialing that in, bringing it in. That field averaged a little over 31 millimeters when we did the measurements. But again, with the exception of this corner up here, all the measurements were in the tolerance. But again, why is it averaging low? Well, it's mostly light green. So in this case, we've set our color ranges to light green being within the low end of the tolerance, dark green being within the high end of the tolerance. So when a field averages a millimeter low and it's mostly green, we can correlate that visual. It starts to make more sense. Again, similar situation on the field in the middle here, 99 measurements, a range of 25 to 38 on a target of 32. This field averaged 31. So again, but it's majority light green and red, so we're not surprised to average a bit low. And then lastly, on the same deal, 100 field in the upper right, 106 measurements. The range was 29 to 36 on the 32 target. In this case, it actually averaged 32. So again, we can see where the colors are helping us out to visualize why that average is making sense. Here's the last case, but it's 2 maps. So bear with me, please. This particular version of the map is a 13-year-old field. Again, green is good, red is bad. There's no green here because this field is averaging 8 millimeters low again. So there is some intriguing, maybe coincidence, but we have a handful of fields that are averaging 8 millimeters low, particularly when they're older. So I don't know if there's something to that, but this field, again, 13 years old. The target infill depth was 38 millimeters. We did 165 measurements. The average was 30 millimeters compared to the 38 target, and the range was 18 to 36 millimeters. And here's that photo I was talking about earlier. Oh, why test 5/8 of an inch of infill? Well, the reality of the range of infill depths is, the 18 to 36 millimeters doesn't tell the whole story, because that's an asterisk where we couldn't measure infill depth in this spot because there wasn't any. So this is an isolated scenario. This is a overlapping baseball and soccer field, and this was wasn't within the batter's box, but this might have been the umpire or the catcher or the umpire were standing. So anyway, there's clearly those scenarios where there's play on fields with little to no infill, unfortunately, and this was one of those scenarios. So with the replacement, here's what the new version of this field looked like. So this was the new install. The target infill depth was 35 millimeters. We did 241 infill depth measurements. The minimum was 30 millimeters. The maximum was 36 millimeters. So pretty tight range, and we're pretty happy with that. However, in this case, the field averaged 33 millimeters. So again, on a target of 35, the field averaged 33. Again, all light green, or the majority is light green. So it makes sense. It's averaging, it's hitting the low end of the very low end of the tolerance that would specify that minus 10%. And to do a little math for you all, that 3 millimeters over this field, which was on the order of 125,000 square feet, equates to about 30 super sacks of infill. So those buying infill will understand that that's a significant amount of material cost, and that's a significant amount of labor. So again, this was a new install, and we did this infill measurements and mapping. And really that's the benefit and the value add to the owner is we understood very completely what was delivered and what was installed, and we're able to find resolution. Otherwise, they would have been left with a field that was 3 millimeters low on infill on day one. So this process is working. Is ultimately, and you're kind of happy with the results and being able to provide that added value to the owner. So moving towards summing up, what we've learned through this process. It's by no means complete exhaustive list, but the key items, ultimately, we're seeing inconsistent infill depths on day one across the board, but certainly, maybe surprisingly, on day one of new installs. Where are those depths? Where are the issues? The sidelines and edges are oftentimes low, as we saw in a handful of those maps. The fields are generally left incomplete. I think the infilling process is best summed up as infill's delivered, it gets dumped in a hopper and spread, and that process, they spread the infill and brush it, and then they leave. That's it. They're not, the installers are not measuring infill depths as they install these fields, and they should be and need to be. They're not monitoring infill usage and kind of how much infill are they using per pass, or to manage, have some data to manage the infilling process. They're not tracking in starts and stops. If you stop, run out of infill in one spot and you start 30 feet ahead of that spot when you refill your hopper, we just have 30 feet of the field that maybe didn't get in a millimeter of infill, right? And then that's carried throughout the field. The broadcast spreader, as you see in the photo here, kind of talked about, this is at a field edge. There's a curb here in the bottom left, and you can see they're throwing pretty close to that, but it makes a real mess if they get much closer by throwing infill outside the field. So we don't know with certainty, but that's, we would certainly pick on a broadcast spreader as compared to a drop spreader, maybe in certain portions of the field or across the field. So there's some opportunity for improvement there. The insufficient infill is being delivered. We've seen on numerous occasions that last case as an example, whether it's intentional or not, an honest mistake to not deliver enough, we don't know. But what we consistently see is there's just enough or not enough infill being delivered to the project site, and this process has, again, I think identified that as something to be aware of and critical of, and confirm you got the material you need on site. There is room for opportunity for sure with coordination with the infill supplier and getting more familiarity with the different infilling materials. It's quite easy, to have an installation crew who's unfamiliar with a particular infill. A quick call and/or meeting on site with the supplier will go a long way with tips and tricks and lessons learned on how to infill that material with the most efficiency. Granted, while you're on site is, preferably that happens in planning phase and prior, or there's experience with that infill. But if there's not, a quick call could go a long way. And lastly, areas, using this picture in the top right here, where we have these deeper purple colors, that's where infill is 5 or 6 millimeters high in this case on that particular field. And it's challenging to move infill that's already been installed, that's within synthetic turf fibers. And again, maybe you're all well aware of that with your own personal experiences, but Again, depending on the synthetic turf carpet specs and how dense it is, or the type of fibers and so on, we're finding it, in areas where the infill is heavy, it's hard to move it from one location of the field to the other, at least with brushing. So this would be incomplete without talking about O&M. This is all sort of predicated on the field, where as infill, under the sort of vision where, as infill gets displaced without replenishment, fibers lay over, get played on, take on more UV, begin to break. That's the beginning of the end of the field. So that leads me to, the mantra of saying the number one maintenance activity is maintaining and managing infill depths. And considering that, we know at this point infill choice impacts O&M, and some infills need a lot more attention and maintenance than others. For example, in different turf carpets, allow for more infill migration. So, but infill impacts, and it's a choice that impacts the maintenance. When you have infill, get it in easy to handle bags or barrels or buckets. You need to have it easy to handle, again, which you all are aware of, but the easier to handle, the easier to get it done. We know, again, we need owners' commitment and to understand the owner's capabilities. And owners would be fortunate to have field managers such as you all, but many times they may not, and they don't understand what decision they're making, depending on an infill choice. And there needs to be a commitment there for maintenance and understanding. Proactive maintenance is longer life. That's going to be obvious to this group, and it rings true with again, managing infill is a critical contributor to maintaining a longer life on the synthetic fields. Refer and use and work within the manufacturer O&M manuals, particularly logging maintenance. If there's a warranty issue, the first thing they can do is ask how the field's been maintained. And if there's no field log, which they recommend, field maintenance log, excuse me, then that might open up some risk. And then lastly, I always like to make sure everybody's thinking about the environment as it relates to maintenance. And again, if you're losing infill, fibers are breaking off, you now have two contributors of materials and microplastics leaving the field, as an example. So just to sort of, I guess, bring some credibility and bring this full circle, I have a couple images here, the front page of a couple more recent studies from 2020 and 2021 that have been published since we started our infill depth work that reinforced the things we've been talking about today. These studies are from our friends at the University of Tennessee and Iowa State and Western Kentucky, some support from some industry equipment manufacturers, and the authors. But the study on the left is a long title, but it's the impact of third generation synthetic turf athletic field age on surface hardness and infill depth, spatial variability. So that's a mouthful, but essentially what that study looked at was similar, it's looked at infill depths and impact measurements with a pretty sophisticated impact measurement tool, and on 12 different fields of varying ages. And the results indicated that as fields aged, they got harder, no surprise, and performance varied spatially across the surface, which was partially attributed to the infill loss and compaction. And it goes on to state that this may indicate the need for targeted infill applications. And as you can see throughout this presentation, we would absolutely agree. And this study too provided a nice figure within it, looking at and mapping the spatial variability between infill depths and field hardness measurements, again, with some correlation where infill depths were low, hardness was high. Study on the right, it's a little simpler to summarize, but it's the impact of brushing and infill maintenance on field safety of 3G turf is the title. I believe it may have been another session actually at the conference. I'm maybe mistaken. But more simply summarized in that it states that synthetic turf surface requires maintenance to keep the surface playing acceptably and consistently, and that field safety and consistency increased due to maintenance, suggesting that brushing and infield maintenance plays a vital role in maintaining high performance 3G fields. And again, we completely agree with that. And it's important to note in both of these cases that the broader and more detailed research is recommended, which is so often the case, but it's always limited. But again, these are two studies, extremely credible groups of people that certainly complement, supplement, and reinforce what we're talking about today. And lastly, some takeaways. Coordination throughout the process, but coordinate amongst all entities during design and install. All infills are not created equal. They all have various degrees of implications in design, implications in installation, implications in O&M, implications in replacement, and so on throughout the project field cycle. Check infield depths. I would say a minimum of 100. The more, the better. As you can see, time and resources are limited, but you'll get a much better picture of your field the more infield depth measurements you take. And from the installation and field construction side, check infield depths before the final sign off on that field. We need to educate owners across the board, and look at this group as a great group that has the experience and credibility to educate your decision makers within your organization, if that's not you, on the various implications that decisions of field materials, in this case, the impact of infill material choice and generally synthetic turf materials. Training across the board for us all, for owners, for field installers. Everybody can use more training. Complete the simple maintenance. It's going to go a long way. There's absolutely opportunity for innovation, whether it be with equipment or improvements in processes or construction installation methods. There's absolutely opportunity there. And then lastly, testing. I think there's a gap, at least, I think as far as I'm aware, in the really detailed implications of what infill depths and different thicknesses of infills and how that really correlates to different performance, typical field performance testing. And how that might impact specifications. And then lastly, just to be a little thought-provoking, as we move forward into the future of data, right? With, in the upper right, we have cameras monitoring field play. We have drones, we have bots, we have virtual reality or augmented reality and various remote sensing. Think about, in the context of infill depth maps that we just looked at, if you threw on a VR headset or held your phone up with augmented reality and you input that infill depth map into your system and you scanned the field and you saw something like this here, right? That where, the red might mean this is where you have to do, your infill depths are low, for example, and you can then focus your maintenance activities and resources there as an example. Or again, in the future, maybe it's a fleet of bots. Maybe they're not just mowing grass, which we know they're not perfect at, but maybe they measure infill depths and maybe they replenish infill. So just curious and really intrigued where the industry goes in that regard. So with that, there's some image source and data credits here to run through. And I thank you all for joining, and hopefully this is somewhat informative and of value to you. So I do see some questions or comments rolling in the chat or the question box. So I will jump over to those and hopefully answer them. So we talked about the map and the plowing. Happy to have helped you out there. There's a question here. Should a combo be used on installation for drops better around the edges and broadcast the rest of the field? Yeah, I think that's a great question. I have the same question. I think it could be. I think it's whatever gets it done, but that seems to be a logical option. As far as infill depth gauge, what type of gauge do you recommend? any gauge, as long as it's getting done. You saw a picture of this single needle. I think a 3-prong infill depth gauge is honestly probably the best. They tend to be a bit more expensive, so a lot of times, we'll use the single prong fireproofing gauge as a really good, quick data point. But again, there's some data variability and there, but either one, I think, as long as it's getting done, you're headed in the right direction. Again, similar, most popular measurement tool or preferred, I think I answered that one, but if you can get the 3-prong, go with the 3-prong, but there's some options and they can get pretty sophisticated. Here's a question, bear with me. Mentioned infill weight earlier. Specs typically have a pounds per square foot threshold. Do we test for this? So yes, I think there's a general pounds per square foot, but that pounds per square foot generally gets translated to, at least for me, what's the infill depth that results in that pounds per square foot. So those are the numbers we're looking at. So yes, definitely specifying a weight. But that's being the only way we'll measure that is through infill depth. But that's an example where I think installers are delivering a certain weight per square foot, but that's based on whatever they may have looked at in the lab, for example, or maybe they didn't look at a lab and they have an older, they did a 1 foot by 1 foot sample to get their spec weight, and maybe the infill density has changed. They haven't measured it recently, so we're definitely relying on the weight being translated to the infill depth. Hopefully that answered the questions there. I believe that is all the questions that came through. I'd be happy if I did not answer your question. I'd be happy. Feel free to reach out. Email is there, and we can set up a time to talk. I'd be happy to. There are a couple more questions rolling in for anybody who can stay. Feel free to do so. Even on well-maintained fields with consistent infill depths, what have you seen for years until replacement? So unfortunately, we haven't been doing this sophisticated of a process. I have same question. For enough time. We're probably approaching the 4th year of this level of effort, and it is a bit involved. So I think what we are seeing is I'm highly skeptical and suspicious that fields historically didn't get infill installed completely. So on day one, it was low, or it was low in certain areas, as an example. So I think, translating to a field that's 10 years old now and say due for replacement, I think it's unfair to assume that all the infill was there on day one. How effective is hand spreading and raking on small areas? I think that's extremely effective. I think that's probably a perfect application of targeted infill maintenance, where in those high use areas. So you certainly don't need to go spread infill across the whole surface and brush the whole surface all the time, but you most certainly need to go to those high use areas such as the lacrosse crease and use a hand spreader, let's say, or by hand. Again, whatever method gets it done and gets the infill back in, encapsulated within the fibers. Watering of infill materials. I won't pretend to be the pro or the expert on installation by any means. So I think I have seen or heard of others watering a field to help with some installation, or maybe some initial settlement, or to deal with some static, for example. So I think that could be a method to deal with certain conditions. So that's possible. But not necessarily, the way to do it for all. And certainly, a natural infill such as a coconut that might benefit from some irrigation, for example, to get the moisture in a place where it's more, not going to blow around, for example. or might settle into the turf system. So I think there's absolutely lessons to be learned, and I would rely on the installers for that. But absolutely opportunity for, again, improvement and experimentation on how to install these infills, particularly the new ones, in the most efficient, most efficient manner. Painting and cleaning effects on infill material itself in depth. I don't want to say too much there because I'm, again, not an expert. I think there's probably a lot of people, in the SFMA and the sports field managers who are going to have better input than I. What I know is I would rely on the synthetic turf manufacturer for their guidance, or whoever's, owns materials or supplying materials in that system, for the specific painting, things to be aware of, as it relates to painting. Because it's just so specific. What type of paint you using? Is it permanent or semi-permanent? It's gonna be there. You want it to be there a long time versus really short term, and you'll be using different materials to get that paint off. So that's a bit too specific for me. But I think certainly relying on the synthetic turf manufacturer or the super knowledgeable, paint material suppliers. So I would refer to them.
I think that's all the questions. If you think of anything else, Thomas's contact information is there on the screen, so feel free to reach out to him. Thank you, Tom. Thank you, everyone, for joining us today. We do have another presentation today, and that starts at 3:30 p.m. Eastern Time. Sam Doak will be presenting pesticide and top dressing calculations. It's only cell phone math. So make sure to register and join us for that presentation in a few minutes. Also, don't miss the presentations featured each Tuesday for the next 3 weeks. You can visit the SFMA website, or emails will be sent so that you can get registered. So thank you, everyone, and have a great rest of the week.